All right, you guys, welcome back. Here's a warm-up I want you to try. Go ahead and hit pause on the video and give it a shot. When you're ready, we'll go over the answers together. All right, convert the following quadratics into vertex form by completing the square. Most of you guys really liked the box method, kind of like imagining what we're doing with the literally completing a square. So for the first one, we start with an x squared box, and there's 6 x's, which means there's going to be 1, 2, 3 rectangles on this side, 3 on this side, just like we did before break, which means there should be 9 pieces in the corner. So what I always had you guys ask was number 1, do we have exactly 9 pieces? No, so it's not a perfect square. Then we say, okay, do we have more than 9 or less than 9? Well, we have more than 9. How many more? 4. So this represented as a perfect square is x plus 3 quantity squared. But we don't have x plus 3 quantity squared because we had 13 little pieces versus this only represents 9. So we actually have 4 extra pieces. And so that's how we would write that in vertex form, okay? So if we do the second one using kind of the same idea, we have an x squared box, and it's negative 8 x's. So that means we're taking away 4 on either side. So there should be 16 in the corner. So that is a perfect square, is x minus 4 quantity squared, because it's x minus 4 times x minus 4, okay? Well, we have 15 pieces. This needs 16. So do we have exactly 16? No. So it's not a perfect square. And then we ask ourselves, do we have more than 16 or less than 16? We have less. We have exactly 1 less than 16. All right, so let's look at the last one over here. Got an x squared box. We've got negative 14. So instead of actually drawing minus 7 on both sides, I'm literally just going to write negative 7x and negative 7x. That's totally fine if you want to do that to kind of cheat a little bit. So in the top right corner, we'd have 49 little pieces. So that represented as a perfect square is x minus 7 quantity squared. We do not have 49 pieces. In fact, not only do we not have 49 pieces, we're in the red, basically 95. So I'm going to add those two numbers together in my calculator. So that means we're actually down 144 pieces. So I know that's kind of a weird one to convert because the number is so big, but that is possible. All right, let's keep going. So remember Optima's quilt shop? She bases her designs on quilt squares that can vary in size, so she calls the length of the side for the basic square x, and the area of the basic square is that function x squared. Okay, and this way she can customize the designs by making bigger squares or smaller squares. Sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders 4 blocks of the basic size, the customer service representatives write up an order that looks like this. Model this area with a diagram. So here's what that means. They've just got an X by X box, but now there's 4 of them instead of just having 1. Okay, so it's a little bit different than what we've looked at before. I think you guys are starting to see where I'm going with this. So number 2, one of the customer service representatives finds an envelope that contains the blocks pictured below. Write the order that shows 2 equivalent equations. So one equation, like in standard form, for example, we say, okay, how many x squared boxes do we have? We've got 1, 2. So y equals 2x squared. Then we say, okay, how many rectangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got plus 12x. And then we've got 9 little pieces here and 9 little pieces here. So total we have 18 little pieces. We could also write it in vertex form though, right? Kind of using completing the square. This right here can be represented as the quantity x plus 3 squared, right? It's x plus 3 times x plus 3. But there's 2 of them. So what's going to change? We're going to tack a 2 in the front. So basically where we're going with this, you guys, is how to complete the square when there's a number other than a positive 1 with the x squared. All right, try these two, pause your video, and when you're ready to see the answers, go ahead and unpause. All right, so for both of these, they received an order for 2 blocks that are squares and both have dimensions increased by 1. So basically you've got, here's x squared increased by 1, but there's 2 of them. And it's saying write the 2 equivalent forms. So in standard form, we could say, well, there's 2x squared boxes, 4 rectangles, and 2 little pieces. Or we could write it in vertex form and say, okay, well, one of those is represented as x plus 1 quantity squared, but there's 2 of those pictures. Same thing for number 4, received an order for 3 blocks where the squares dimensions were increased by 2. So if we were to draw that out, it would look like that, but 3 of them. I know my drawings aren't perfect, so bear with me. So in standard form, we have 3 x squared boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rectangles. And then 4 plus 4 plus 4, that's 12 little pieces. Or we could say we have 3 different diagrams, right? 1, 2, 3 different diagrams that are all x plus 2 quantity squared. All right, try this question and then we will talk about it together. So pause it, give it a try, and then we'll go over the answers together. All right, so basically what I want you guys to do is to complete the square, right? So what I would do is I would just draw the picture. So there's 2x squared boxes. Okay, so here's my 2x squared boxes, and there's 8 rectangles total. So here's what that means. There needs to be 8 total in this entire picture. So if there's 8 total, there's going to be 4 rectangles for the first guy, 4 rectangles for the second guy, which means there's 2 on each side. So total, I've got 2x squared boxes and I have 8 rectangles. There's going to have to be 4 little pieces in the corner. So what would we need? We would need 4 plus 4, which is plus 8 to make this a perfect square. If I do the same thing down here, I need 3 x squared boxes. And there's 24 total rectangles. Well, 24 divided by 3 means there's 8 rectangles for each one. And so there's going to be plus 4x on each side. Okay, this one I'm kind of cheating a little bit by just writing plus 4x just to save on time for the video. 4 times 4 is 16, so there's going to be 16 little pieces in each of those corners. So 16 times 3 is 48. So we would need plus 48 little pieces to make it a perfect square. So this top one up here, written as a perfect square, so here's the standard form version. Vertex form version would be 2 times the quantity x plus 2 squared. For that bottom one right here, here's our standard form equation. In vertex form, it would be 3 and then x plus 4 quantity squared. Remember, if you have questions about this or you're kind of stuck, you can pop in for office hours today and I can try to clarify because I know I'm going fast. But remember, it is a video, so you can always pause at any point in time, okay? All right, so now here's a real mess. Customer service received an order for an area of this one. Help them figure out an equivalent expression for the area. So basically what I'm looking at is normally in class I would actually move the pieces, like literally put them together. I'm going to give it a try, but my concern is that it's going to be tougher to move each of them over and over again. Because my idea was like something like this, you know, where you try to put them all together. So I guess it's not going too bad. So basically, we're just trying to figure out, okay, what would this look like written as vertex form is kind of the idea. Okay, so this is just going to take a second. I'm going to move these guys out of the way here. So this is way cooler when I do this in person in class, but this will just have to do. I know it's not perfect, but I only have 15 minutes for my videos, so I want to make sure I'm not taking up too much of your time. Okay, so here's what I'm going to do. So now these little pieces, there's going to be a bunch of them like when we move them. So I'm going to try to complete this square as much as I can. So there's 9 in this corner. But if you notice, look, oh, well, shoot, we don't have a perfect square over here. We're close, but not quite. So here's what we do to write this as vertex form. Here's the standard form version. Vertex form, the closest perfect square we've got is 2 times the quantity x plus 3 squared. But notice we don't have that. We're missing some pieces. In fact, we're missing 1, 2, 3, 4, 5 pieces. So how do we adjust that? We write minus 5 at the end. And so we just converted from standard form to vertex form using this idea. Okay, so try This one right here, pause it, and let's see how you do. All right, so this one, I'm not going to actually move the pieces just because that was kind of time consuming. But I know there's 3 blocks and there's 6 X's, but there's 3 of these guys. Okay, so I'm thinking, okay, so I'm going to put 2 of these guys with block 1, 2 with block 2, 2 with block 3. So basically it'll look kind of like this. So in vertex form, there's 3 diagrams, and each diagram is going to be x plus 1 quantity squared in a perfect world. But what that means is we only need 3 little pieces. We've got way more than 3 little pieces. Once I get rid of the 3, I've still got 1, 2, 3, 4, 5, 6, 7 pieces left, which means I have an extra 7 pieces. So this is how you would write that in vertex form. All right, pause your video, go ahead and try these 4 questions, and then when you are ready, we will go over the answers together. All right, so we want to try to find the perfect square that's closest. So these first 2, we're actually going to skip these because they're just like the ones we did on the warm-up, right? Where it's just 1x squared box, nothing too crazy. What I want to focus on is these guys down here, okay? So if I look at letter E and I kind of visualize, I have 3x squared boxes. So I'm going to start there. And I have negative 30x like rectangles, which means I'm going to have negative 10 rectangles for each box, which means there's going to be negative 5 on each side. Okay, negative 5 times negative 5 is 25. So in a perfect world, we would have 75 pieces. We'll take a look. We have exactly 75 pieces. So yes, this is a perfect square, which means we're just going to write it as 3 times the quantity x minus 5 quantity squared. Versus, let's take a look at f, because I bet you f is not the same thing. All right, I got 2x squared boxes, and I have negative 22x, which means you need to have negative 11 rectangles on each side. Well, negative 11 is an odd number, so it's kind of hard to figure out what's going to go on each side. So what we're going to do is we're going to put 11 divided by 2 is 5.5. So I'm going to have negative 5.5x on either side. And I'm going to use my calculator to square that, and it's 30.25 little pieces in the top right corner. So in a perfect world, my vertex form equation would be 2 of the x minus 5.5 quantity squared diagrams. But 30.25 plus 30.25 is 60.5. We only have 11 pieces. That means we're down some numbers. So 60.5 minus 11, okay, we are down 49.5 little squares. So remember, the idea is to go from standard form to vertex form when there's a number other than 1 in the front, okay? All right, you guys, I'm going to do another video that kind of dives in deeper to this. So you might see a part 2 video, but so far, I think we're doing good. So nice work.